Bismillahirrahmanirrahim. Assalamualaikum everyone. Today we continue our lesson topic 2.17 partial derivatives. Before we move to the example, here we have notes about the partial derivatives. How can we know that we have to differentiate the function using partial? Okay, you can see that normally the question asks you to find f, and then here we have x, okay, small x. What does it mean by this? Okay, you have to differentiate the function contain our variable x and y. Okay, differentiate the function with respect to x. Okay, means that you have to treat y as a constant. Okay, here we can see our first example. Okay, our first example function contains x and y. So let's say you have to find fx, you differentiate the function, but you have to make y as a constant. Remember before this, if you see any constant, first you bring it in front and then you differentiate only the variable. Okay, so we do the same for this function, for this example. Okay, and one more thing, right now if we see any constant, differentiate constant, we get 0. Okay, so the second one here, just now we have x, and then here we have fy. Okay, when we see small y here, okay, you have to differentiate the function with respect to y, and then you have to treat x as a constant. Okay, actually this topic is maybe quite simple compared to the previous topic. Okay, now we move to the example 1. Our function fx equal to x cube minus 3x square y plus 3xy square plus y square. Okay, we can see that the function contains two variables. Okay, for the function for the question you have to find fx, means that we have to differentiate with respect to x, and then it's a constant. So remember, just differentiate as usual. So now we get 3x square, and then minus. Okay, remember how I treat as a constant, so I just bring it in front, 3 and y. Okay, because of y is a constant. Now we differentiate x square. Differentiate x square, we get 2x plus, okay, our constant 3y square. Differentiate x, we get 1 plus, okay, now y square constant, we get 0. Okay, simplify, 3 square minus 6, okay, 3 multiply 2 get 6, 6xy plus 3y square. Okay, that's all. Okay, how can we find fy? Okay, now x as a constant, so when x cubed is a constant, we get 0. Okay, minus 3x, okay, x is a constant, so differentiate y, we get 1 plus 3x, differentiate y square, we get 2y plus differentiate y square, we get 2y. Okay, simplify, negative 3x square plus 3 multiply 2 get 6 xy plus 2y. Okay, now we have another letter after x. Okay, means that you have to apply second derivative with respect to x. Here we have x. Using the same, okay, the same solution, the same answer that we get for a. And then we differentiate again for second one, but with respect to x. Okay, now we get from 3x square, we get 6x minus, okay, now our constant is y, right? So negative 6y, differentiate x, we get 1 plus, okay, now 3y square is a constant, so plus 0. Simplify, we get 6x minus 6y. Okay, now for question D, we have fyx, so we have to use this one, answer in B. Okay, differentiate respect to x, so now we get negative 3, okay, 2x, okay, 2 we bring it in front, okay, negative 3 2x plus, okay, 6 we have here our constant is y, 6y, right? So differentiate x, we get 1 plus, okay, now differentiate 2y, we get 0. So simplify, we get negative 6x plus 6y. Okay, and then for e, f(x)(x) differentiate 3 times. Okay, we use answer in C, and then we have to differentiate one more time. So differentiate 6x, we get 6 minus, okay, differentiate negative 6y, constant, we get 0. So the answer is only 6. Okay, so I hope you understand for the example 1.